A collection isn't a big mystery, it's simply an object that represents a group of related objects. In general, the objects in a collection share some common relationship or purpose. In computer science, different types of collections have specific names and expected behaviours. These include arrays, lists, vectors, sets, queues, tables, dictionaries and maps, not geographical maps but data structures that map keys to values. These collections are differentiated by how they store objects in memory, how objects are retrieved and ordered, and whether they allow null values or duplicate entries. Oracle's Java documentation describes its collections framework as a unified architecture for representing and manipulating collections, enabling collections to be manipulated independently of implementation details. That's a mouthful, but the term manipulated independently of implementation details should give you a hint that it's based on interfaces. If you're interested in reading the Oracle documentation, they have a good overview at the following link. This was written for JDK 8, but it still applies. Let's take a quick look at this. This page gives you the high-level overview of what's in this framework and the advantages of using it. You can see it consists of interfaces and implementations, meaning concrete classes. I really like the matrix of information they show here, listing each class by its interface and the conceptual type of collection it represents. If you're coming from another programming language, this will be very helpful for you. You can see list, deck, which is a double-ended queue, array list, and linked list represented there. Further down you see a list of the concurrent collections. I will be covering concurrency in a later section of the course. Finally, let's take a quick look at the design goals. What I want to specifically point out here is the explanation of how they decided what methods would be part of the core interface. First, it had to be a fundamental operation, or there was a compelling performance reason to implement it or support overriding it. I'll be talking about what methods are on collection interface and classes and what methods are available to you on another helper class I haven't yet talked about. Strictly speaking, arrays and the array utilities in the java.util.arrays class are not considered part of this framework. All collection objects implement the collection interface with the exception of maps, and I'll explain why in this section. The collection interface is the foundation of the collection hierarchy in Java. As with most roots and software hierarchies, it provides an abstract representation of the behaviours needed to manage a group of objects. This interface is often used when you want to pass collections around and manipulate them with maximum flexibility and generality. Remember, an interface allows us to define objects by what they can do rather than by their specific structure or implementation. If you examine the methods in the collection interface, you'll see the fundamental operations that any collection, regardless of its specific type or structure, must support. We've already explored these operations in our discussions on ArrayList and LinkedList. When managing a group of objects, you'll typically be adding and removing elements, checking whether an element is present in the group, and iterating through the elements. There are other methods as well, but these are the core actions you'll use to manage a collection. In Java, the term element refers to a member of the collection being managed. You might be wondering why sorting isn't included as a method here. Don't worry, I'll explain that shortly. Let's jump into IntelliJ and see what we can do with this interface. I've created a new project called Collections Overview for this video. First, I'll create an empty array list of type string and assign it to a list local variable. I'll now create an array of strings, and I'll use an array initializer to assign the names Anna, Bob, Carol, David and Edna to that. I'll add these strings via a call to add all, nesting a call to arrays.asList. Then I'll print the list. This should be familiar ground for you by now. Running that, I get all the names printed out. I'll add a couple more statements, again just using methods I showed you that are defined on the collection interface. I'll add another name, Fred, and 3 more via a call to add all and as list as I did earlier. I'll print what we have. Is Gary in the list? I'll use list.contains to print true or false. Running that code, you can see Fred, George, Gary and Grace are listed, and the code confirms that Gary's in the list. I'll add a remove if statement for good measure with a lambda expression, which will remove any names from the list that start with G. I'll achieve this by checking if the char at position 0 is the character G. and I'll copy the two system.out.println statements from above and paste below. Running that, you can see this code removed all the names that started with G, so Gary isn't in the list any longer. These are all methods defined on the collection interface, executed on a specific implementation, the array list, but assigned to a list variable. I can actually abstract my variable type further to collection. I'll do that now. I can still add elements and check if an element is in the collection. All of my code compiles and runs as before. Okay, so this is nothing new or exciting, just to recap on how interfaces work. Next though, I'll change ArrayList to say TreeSet in that first statement. TreeSet is a different implementation, meaning it implements the collection interface, and don't worry, I'll be talking about this class in detail coming up. Right now I just want to swap out my collection type for another that is significantly different from an array list. If I run this now, you can see that this code still runs and the output is the same. I'll try a different implementation, hashset. This compiles and runs too, but the output is different, isn't it? The elements aren't ordered. Not all collections are implicitly ordered by the way you add the elements, the insertion order, in other words, like lists are. What if I wanted to sort this? Can I just call the sort method on list as we have done previously? I'll add that statement, calling sort on my list variable right below the last println. But this doesn't compile, and if I hover over that, the error says cannot resolve method sort in collection. The collection interface doesn't have a sort method. The list interface does, but the collection interface is more abstracted than a list. Another thing to know about the collection interface is that there aren't any direct implementations of this top-level interface. Other interfaces are derived from it, and implementations or concrete classes implement the derived interfaces, like list and set. Let's look at this on a slide for an interface we know pretty well by now, list. This slide shows the list interface extending collection. For simplicity, I'm not showing the collection methods that I showed on the previous slide. I'm only showing additional methods specifically declared on the list interface. I've covered most of these methods, but I wanted you to see here that most of these are dealing with an index. A list can be either indexed as an array list or not, like a linked list, but a linked list is implemented to support all of these methods as well. Derived interfaces may have specific ways to add, remove, get, and sort elements for their specific type of collection, in addition to those defined on the collection interface itself. Right, so let's look at the big picture of interfaces and some specific implementations. This slide shows the interface hierarchy. It's also showing the implementations or concrete classes that implement these interfaces in yellow font. Notice that map does not extend collection, although it's still part of this framework. Maps are uniquely different, which I'll be explaining when I cover maps in this section. You can see that linked list implements both list and deck, and I discussed this in detail when I covered linked lists. A list is an ordered collection, also known as a sequence. These can be sequenced in memory like an array list, or maintain links to the next and previous values as a linked list. A queue is a collection designed for holding elements prior to processing. In other words, the processing order matters, so the first and last positions, or the head and tail, are prioritised. Most often these may be implemented as first in, first out, FIFO, but can be implemented like a stack as last in, first out, LIFO, which we've discussed. Remember, a deck supports both. A set is a collection conceptually based off of a mathematical set. Importantly, it contains no duplicate elements and isn't naturally sequenced or ordered. You can think of a set as a kind of penned-in chaotic grouping of objects. Java has 3 implementations, which I'll be reviewing in this section of the course in detail: the hash set, the tree set, and the linked hash set. These are distinguished by the underlying way they store the elements in the set. A sorted set is a set that provides a total ordering of the elements. More on this later in this section. A map is a collection that stores key and value pairs. The keys are a set, and the values are a separate collection, where the key keeps a reference to a value. Keys need to be unique, but values don't. Elements in a tree are stored in a key value node, also called an entry. In the videos coming up, I'll be looking at set and map, and how they resemble and differ from list. But before that, I want to talk about polymorphic algorithms. Oracle's documentation describes a polymorphic algorithm as a piece of reusable functionality. At one time, most of these methods were provided to us as static methods on a class called java.util.collections. Since JDK8 and the advent of multiple interface enhancements, some of these methods are now on the interfaces themselves as default or static methods. But not all are, so I'll be discussing this class and what it has to offer in comparison to what's available on each collection class. It's also important to understand that legacy code will be using this class for some operations that can be done from the class itself. I'll comment out that last line of code so that the class still compiles. Coming up, I'll be talking about this helper class and its methods. There are some fun polymorphic algorithms on there I haven't covered, so I'll see you in the next video.